In the next few lectures, we're going to discuss how to compute areas of regions that are bounded by more than one curve. And so to get an idea of how to do that, we'll first review how to compute the area under the graph of a single function, f of x, using the Riemann integral. So suppose we have a function f of x, and we sketch its graph in the xy plane, here to the left. And what we're interested in computing is the area of the red shaded region, here under the graph, in the interval between a and b. The idea is to approximate the curved region with rectangles that are easier to compute. And so what we do is, first we subdivide the interval from a to b to little subintervals, like so. And then we use these subintervals to draw approximating rectangles. Now we want to compute the area of a single rectangle. Which would be height times width. So we mark off a point in one of these rectangles. Let's call it xi star. And so we need to figure out the width, which is delta x, and the height. So the height is given by the y value here, which is the function value at this point. So the height is f of xi star. So we get the area of this one rectangle as f of xi star times delta x. Now, to approximate the area of the region, we have to add up all the little rectangles. So suppose there are n of them. So we sum over the n rectangles, and the area of the individual rectangle again is f of xi star times delta x, and so this will be the approximate area. Finally, to get the actual area, we take the limit of this sum as n goes to infinity. So we take the limit as n goes to infinity because as we increase the number of subintervals, the rectangles get smaller and smaller, and so the approximations get better and better, and so this will be the actual area. And this is defined as the definite integral from a to b of f of x dx. So to give a rough summary, each part of the integral represents part of this process of computing the area. Right, so here the dx represents the width of a tiny rectangle, the f of x represents the height of a tiny rectangle, and the integral symbol represents summing over the entire interval to get the actual area.